Today, I would like to talk about fear, about scary stuff. Not in general, of course, but about a specific kind of fear. Have you ever heard of chemofobia? Chemophobia is a word that stands for fear of chemistry. Chemophobia is the irrational fear that chemistry is a synonym of danger, pollution, and damage to the environment. Today, we will try to challenge this prejudice that is very common in a positive and constructive way. This means that we will try to highlight, to point out, that chemistry can play a very important and also surprising role in limiting and controlling the environmental impact. It may seem a little bit provocative, but I ask you to follow my reasoning. Of course, we don't want to belittle or deny the wrong use of potentially dangerous products by some industrial producers, but for sure, we want to fight against the word chemophobia, offering a different perspective about this subject. I am Davide Trentini, and this is Apparently Invisible: Chemistry in Ceramics. Since the topic is today, as you can imagine, quite delicate, I would like to start with an introduction. Also saying that we will address the topic that is very long in 2 different episodes. We will start today and we will end in the next episode. So today, as I told you, we will try to refocus from a special and some way provocative perspective the role of chemicals involved in the ceramic production process, from the beginning, that is the grinding stage of clays and inorganic materials, to the end inside the kilns. We will use a filter or an approach that is chemicals and environmental impact, trying to break the preconception about the word chemistry. Probably some of you will disagree, but the challenge is to offer a different point of view, just to open a discussion. And if we looked closer at chemicals for ceramic production, we would discover that their alleged danger does not make any sense. On the contrary, sometimes they can promote some environmental improvements that should not be underestimated or even disclaimed. So, we will proceed along the production line, highlighting the strength about chemicals and sustainability by showing their positive contribution. Is this a provocation? Yeah, probably. But is this food for thoughts? For sure. And so, let's start from the beginning, that is, from the grinding of ceramic mixtures. As we know, ceramic mixtures basically consist of clay, more or less plastic, and hard materials such as feldspar and sands. Once they have been selected, raw materials are processed in the grinding mill, within which a proper amount of water is added, of course, to properly develop the process. Raw materials, together with the water, forms, of course, the slurry, the so-called barbottino. Even if slurries can be very different one from the other, they usually contain the same water amount, that is normally about 35%. And this is a rate that ceramic producers always try to reduce with different actions to increase the solid amount inside the suspension. Why? I try to explain you taking a small step back. After the milling process, the slurries enter the atomizers to lose, by evaporation, the liquid part of the suspension, except for a low amount of residual humidity that is about 5-7%, we already seen. This is very important to form the atomized ceramic powder that, under the weight of the press, will produce the raw ceramic tile. The water elimination takes place thanks to the use of a very high amount of energy, that is, a high energy consumption. And here is the point. The higher the water content, the greater the energy used. And this is, of course, a synonym of greater environmental impact and, of course, of cost increasing. This is the reason why producers always try to work with slurries marked by high density, that is, slurries marked by high solid contents and low water contents. We should also underline that the combo more solid and less water usually allows you to produce, within the atomizers, a higher amount of atomized power, considering, of course, the same volume of slurry. To put it shortly, the lower water amount decreases the environmental impact thanks to the reduction of gas and so energy inside the atomizers, and at the same time it increases the productivity by producing greater amount of atomized powder. So the question is, how can chemicals involved at this stage of the production process promote a reduction of environmental impact? Here is the answer. The use of proper dispersants that are specifically studied to provide the slurry with the right viscosity values allows you to correctly develop the production process and to reduce the water amount in the suspension. That means that their fluidifying action, in other words, is synonymous with energy reduction. But there's more. The reduction of energy consumption can also be improved or promoted by using temporary binders. Why? And even in this case, I take a step back by saying that tile's mechanical resistance usually derives from the presence of plastic clays that, however, can be at the same time responsible for a difficult fluidization of the ceramic mixture. In fact, since they absorb significant amounts of water, plastic clays usually force producers to increase the water amount inside the system, that is, the barbotin of course, to improve the flow, we could say the movement, of the clay bichales in suspension. Okay, the excessive reduction in the use of plastic clays could be useful to increase the slurry's density values, but it is surely not recommended if you don't want to negatively affect the values of the raw tile's mechanical resistance. However, temporary binders can rebalance most of the values, also reducing the environmental impact. How do they do it? Well, they do it by restoring the mechanical features, avoiding breakage of the raw ceramic tile, by reducing the use of plastic clays, and by increasing the density value of the slurry, resulting in the reduction in the use of water. That turns into a reduction of energy consumption and into an increasement of the productivity. And here we end with the section about the grinding process, entering along the glazing line where glazes are applied. Let's see what happened. Ceramic glazes can be applied by means of several systems, but as we know, the airless spray application is for sure the most common. This is an application system that is excellent and usually easier to manage, but it can be critical in terms of material waste and maintenance by the operator. What does that mean? It means that the spray cabin must be provided with very powerful suction systems, capable of collecting and recovering the so-called overspray that could spread in the working environment as well as inside the cabin, where it could encrust and improperly drip on the tile. So in this perspective, the amount of material collected by the suction machines, that is non-recoverable glaze, usually ranges from 15 to 30% of the glaze or engob, of course, applied. This rate also includes the wasted glaze inside the cabin that is normally, and we could say optimistically, washed at each work shift. And of course, waste materials is obviously synonymous with environmental impact. Today, I don't know why I like to use these words synonym and synonymous. Forgive me, it's the words of the day. Anyway, this is what happened from the waste side. However, together with these topics that are all about waste, the airless application is also marked by other interesting criticalities that, of course, can be solved, but that must be carefully checked to promote a proper application process and produce high-performing tiles. What are these critical issues? Well, the machine management and the spray nozzle deterioration play from this perspective a very important role. Nozzles, in fact, tend to widen their diameter over time, increasing both the weight of the glaze applied on the tile and the material waste. Since the glaze is improperly applied, the tile can also be easily compromised, and moreover, the temporary obstruction of the nozzles can affect the industrial yield, forcing producers to discard the defective material that have been produced. But how can we handle these problems, and what has this to do with the environment? Let us proceed step by step, also broadening the perspective. You need to know that in recent times, several machine producers have entered the market with new types of glazing machine based on a highly innovative application system. And among the several features, the most significant is all about the possibility or ability to discharge the glaze exclusively on the ceramic support, drastically reducing waste and offering, at the same time, an automated management of the machine thanks to the presence of control and automation system, as it happens with digital printing machines. That said, let's see a little bit closer the chemical's role. As it happened in the past with traditional application systems, even with this new technology, it is important to define in advance the parameters of the glaze to develop the best performance. Depending on the glaze discharging system, in fact, it is very important a detailed study of the rheology, of the surface tension, of the pH, etc., etc., etc. And in this respect, the role of chemicals, whether they are surfactants, rheological modifiers, wetting agents, lubricants, or dispersants, it is certainly fundamental. Of course, this is clear, but it may seem less obvious to underline the environmental implications promoted by chemicals involved at this stage of the production process. The reliability of the new glazing technology, together with the proper values of the glaze, promote, in fact, a productive continuity, allowing you to apply on the raw tile a minimum amount of glaze, so avoiding waste of material and reducing the maintenance of the machine, that is, waste of water. These parameters, of course, are clearly related to the environmental impact, because the washing times of the tools, together with the water consumption, can negatively impact on both productivity and ecosystem. Okay, before proceeding, I just want to clarify that we don't want, of course, to promote any application technology more than others. We just would like to offer a vision about what is entering the market to highlight how the choice of the right chemicals in the different scenarios, instead of being harmful, can lead to important benefit. So, beside the application technology, how can chemicals applied along the glazing line reduce the amount of water consumption, decreasing therefore the environmental impact? Well, ceramic glaze applications, since we are talking about watery suspensions, obviously involve a significant use of water that, once it has been discharged on the raw tile, it is partially absorbed by the support and is partially evaporated due to the temperature of the tile that was previously inside the dryers, where temperatures are obviously important, not only for the proper development of the evaporation process, but also for the proper leveling of the glaze on the support. The water that has been absorbed by the support, of course, must be also eliminated by evaporation in the preheating phase of the firing cycle that takes place inside the kilns. And as you can imagine, even this process, like happens inside the dryers, involves an important use of energy, because even if it's obvious, evaporation means energy. Normally, the greater amount of water is absorbed by the support, the longer will be the time of the ceramic material in the preheating stage. This means to produce a greater energy consumption, that is gas, to evaporate the residual moisture with a gradual and calibrated water release, avoiding breakage of the material. We can also add that if we decreased the amount of water along the glazing line, we could also potentially, reduce the temperature of the tiles that leave the dryers, and this is the first reduction of energy consumption and the energy released inside the kiln, and here is the second reduction of energy consumption. So, going backward, what action can be taken to reduce the water amount of glazes and engobes? To reach the same application performance, the reduction of water should go hand in hand with an increase in the density of the glaze, or of the engobe, of course. And to make this happen, it is necessary to previously study inside the lab all chemicals involved both at the grinding stage and along the glazing line. In particular, during the grinding phase, dispersant and binders must be added to get, or to reach, high density values during the application along the glazing line. That means that we must be aware of what will happen after the milling stage and during the application process. It may seem trivial, but believe me, it is not. And once we have taken the proper decision during the grinding stage, we can also act to reduce the amount of water that is usually added along the glazing line by using leavening agents or other kind of chemicals able to act on the glazing drying and drainage time. In short, the action promoted by these chemicals affect the glaze performance, causing good results even with the glazes marked by very high density values. I stop here and I let you think about what we said. Of course, the topic is not easy and it's controversial, we know it, but I insist, we can address it from a different point of view, or at least we can open a discussion. As I told you at the beginning, in the next episode, we will continue our journey stopping along the glazing line and deepening the grit application process by using the same perspective. And we will finally end inside the kilns, where, as we will see, we collect the fruits of the previous actions. I thank you as always for your attention, and now I just have to say goodbye, reminding you that all episodes are freely available not only on the main platforms, but also on our app that you can download for free on Apple Store or Google Play. You just need to type Z and S Ceramco, Ceramco. Don't be scared, I will be here very soon.